Bismillahirrahmanirrahim. Assalamu alaikum. My name is Hafiz Talha Habib and my registration number is 17 NTU 1122. I am from BSCS Morning 6th semester. My topic of presentation is Software Engineering Architecture Driven Software Development. There are two major contents in my topic. The first one is general categories of design and the second one is stages of the software development. First, we discuss general categories of design. What is general categories of design? The software engineering integrated product team is responsible for developing and controlling the software architecture and its integrated design and configuration documentation. The software architecture must characterize the design of the software product to be developed. This necessitates the crafting of different types of design diagrams, views, and documentation that depict the software architecture. General categories of design includes five major factors. The first one is descriptions of the functional architecture and its design representations such as functional specifications, functional decomposition hierarchies, data flow diagrams, behavioral models, and data dictionaries. The second one is descriptions of the physical architecture and its design representations such as interface block diagrams, structural specifications, and configuration, assembly, and integration plans. The third one is requirements baseline and its representations such as software requirement specifications, software interface specifications, and database requirement specifications. The fourth one is description of the computational environment, and the last one is post development process specifications and design documentation. Now we can discuss the second major content of my topic. This one is the stages of the software development. In these stages there are 8 different models that we discuss as so on. The first one is functional behavioral model. The functional behavioral model provides the functional flow, control flow, data flow, timing, error detection, and handling procedures and resource utilization characteristics of the software solution. The behavior model is derived from the operational model and decomposes operational activities into the deliberate behaviors the software product will be fabricated to processes. What is functional hierarchy? The functional hierarchy stipulates the layered breakdown of functional complexity to elementary, uncomplicated functions. Topmost functional components are decomposed into lower level components to provide a logical framework for deriving software behaviors. Lower level functional components must be further decomposed until units are perceived. Functional units represent elementary functions that can no longer be decomposed or of which the effective and efficient formulation does not warrant further exploration or decomposition. Here the third method is database transaction behavior diagrams. In database transaction behavior diagrams provides a behavioral representation of each database transaction the software product must support. These diagrams should identify the database tables accessed, the expected responses to transaction queries, and transaction rollback procedures. Here is an user interface functional hierarchy. This hierarchy depicts how much user interface functional mechanisms have been grouped into functional components, subcomponents, and finally to functional units. Now here we have conceptual component block diagram. This diagram provides a layout of conceptual components, the interfaces among components, and interfaces with operators, and interfaces with operators and elements of the computing environment. Now here I discuss some software test cases. In software test cases, The software test cases should be identified by tracing operational threads of behavior in the operational model. Each operational thread represents a unique test case. Each test case should identify the set of conditions under which a data processing transaction is exercised and the criteria for determining that the transaction has been satisfied or not. Here we have updated requirements traceability matrix. The requirements traceability matrix must be updated to reflect the evolving elements of the functional and physical architectures and software test cases. Here's the last one is updated nomenclature register. The software architecture dictionary must be updated to reflect the elements of the functional and physical architectures. Here we need to know we have must be updated to reflect the elements of both. The first one is functional architecture and second the physical architectures. This is our updated nomenclature register. Now we move to our last diagrams. This is very useful and helpful to understand what are these two major contents that we discussed. Here we have a flowchart of architecture driven software development. This flowchart is very helpful for us to understand the complete topic. Here we can see the first table, architecture driven software definition, software requirements definition. Here we have some attributes, operational models, software test plans, software requirement baseline, software requirement specifications, verification, and after verification we have a second table, project management. Here in project management we have objectives and constraints. We have to must fulfill these objectives and constraints. Here after this we have a plans and schedules. Here and the next one is very important attribute, the budgets. We always must calculate our budget before we have to design any software. Here the last is change proposals. After verification we have add software acceptance and testing. Here these in this table we have some attributes, test conduct, software test reports, viewers and derivation. Now again verification, preliminary architecture definition, functional behavioral model, functional unit space, functional architectures, and after trade study, project control. Now we discuss the table of project control. Here we have software engineering, software requirements analysis, control, verification and validation, software design and synthesis. And here after validation we have software implementation, C agile integration and testing. This is very important. And software components integration, and after is dry run acceptance testing. This dry run is very helpful to know about our logics that we apply in our software. And here is in the last row we have again verification, detail architecture definition. In this we have some attributes, physical architecture, physical unit spaces, software integration strategy, unit interface, and in last column we have software implementation. After complete our project and after complete testing, now the last step to implement our software. In implementation we notice some attributes, C agile unit development. Here attributes are software unit design, software unit coding, software unit testing, software development folders. So this is my presentation of architecture driven software development. I hope you like it, ma'am. Thank you. Jazakallah. Allah Hafiz.